Hello everyone, this is Sam Herzog again, and just to introduce myself, my name is Sam Herzog and I have done network engineering for 12 years. I currently hold a CCNP Enterprise and I'm also studying for my CCIE. These short videos are done to help me reinforce and prepare for my CCIE, and at the same time these videos are forcing me to revisit old and new network principles, but also to share my knowledge with the network community. So without wasting time, I will get started. So this video series started with the DHCP snooping video, and this is the second part, dynamic Arp inspection. The initial configuration implementation has been done. We've run some debugs while doing DHCP snooping and configuring DHCP snooping. But let's proceed with Arp inspection. So Arp inspection and DHCP snooping work hand to hand. What that means is that Arp inspection uses the DHCP snooping database in order to make sure that the mappings are, when a customer requests for an Arp, it has an Arp request, the Arp inspection makes sure that the customer is who he is and the responder is, or whoever replies to this Arp request is who he is, right? So let's start. So we'll remember this lab. In this lab we had two switches, one gateway and one user access switch, an external connection, and I had two endpoints, Joe and Chloe, and on this lab for Arp inspection demonstration I've added Pierre, who would be the attacker, and or the man in the middle. So let's get started. Right now, just a quick overview of the DHCP configuration. We have excluded 1 and 2. We've created a user pool with this network, this gateway. Okay. Also, we've got an SVI who is our gateway, which is 200.1. We've also enabled, well, it's not, so we'll enable them. We'll debug IP DHCP server events, and we'll do packets. Okay, packets. Okay, and also I have created an access list. I didn't mean to bring all this out. I created an access list 4 and 6. So let's add some more IP to this, so I don't have to keep modifying this IP, this access list. It's a standard list, right? So what we'll do is we'll permit 192.168.200.5, and that's a host that we're permitting. So let's make sure that we've got that in there, and we'll log it. And also we'll enable so we got 4, 5, and 6. Okay, I think that's about it. Okay, so let's verify again one more time. There we go. We have 4, 5, and 6. The reason why I did this is because I like to make sure that my DHCP has all the addresses that could be, offered to Joey and Chloe. The reason behind that is one of these addresses will be used for Pierre. So why don't we exclude? Well, I'm not going to exclude. It's going to introduce IP duplicates on the network, but it may as well. Okay, it isn't. I guess it's fine. An attacker would know what the gateway is, right? So let's make it as realistic as we can. So debug IP routing, then debug IP, I think it's packets 10. Okay, so let's do this both. All right, let's clear it. All right, there. So remember this, as soon as, so what does ARP does? ARP inspection. ARP inspection looks at the DHCP, the snooping binding database, right? What is, let's check if we have DHCP snooping binding database. We have two IPs. We have 4 and we have 5. But we do not have 192.168.201, which is the gateway IP, right? So if you enable ARP inspection, what would happen to that IP? Most likely it will get blocked or denied, right? It would get denied because it is not part of this DHCP snooping database, and because not part of this database, ARP inspection assume that the user isn't permitted to do business on the network, or ARP, or request any ARP, or respond to any ARP on this network. So let's enable it. Enable it on Vlan 10. So now let's try a ping and let's see what happens. I believe 4 and 5. Is it? Let's try again. There we go. And you will see, it takes a second, and you see that a response, a VLAN invalid ARP response on 02, right? VLAN 10 from the gateway, and that's the IP going to Joey, or is it, no, Chloe, which has the 4, right? So there is an invalid ARP response on 02, and 02 is one of the members of port channel 10, right? It's got two members, G02 and G03. Let me show you. See the connection between switch 1 and switch 2 on 02 and 03. Okay, perfect. All right, so again, ARPs are being, the ARP response are being denied, right? A ping to 4, he knows whose 4 is, right? So if you do show IP DHCP bindings, right, he knows who 4 is, right? He's got an entry in his DHCP binding, obviously, but this user is Chloe requires an ARP reply, right? And this is it, and it's being denied. Let's allow now this by creating, because static IPs are not going to be filtered. In order to allow them, because they don't exist in the snooping database, we have to implicitly, actually explicitly, we have to create an ARP access list to allow those response. And so let's do this. So we're gonna, since it's only denying the response, why don't we write 1? So only trusted, right? We're gonna permit, why don't we just permit host IP, host 192.168.200.1, right? And then MAC host, we're going to grab his MAC address of VLAN 10. There we go. And then we'll do this. So show access list trusted. Let's see what we got. We have this host and his MAC, so we're permitting it. So what we could do now is apply this inspection filter, right? Trusted on VLAN 10, right? As soon as we do that, now switch 1 is able to reach either Chloe or Joey. Okay, that takes care of that. Okay, now we have Pierre. Now Pierre comes in because of DHCP snooping. Is obviously, let me show you guys how Pierre is configured. So Pierre, I already pre-configured this to save some time, has a DHCP server configured, right? I've excluded one, myself or Pierre, and the pool has a network and a gateway of 3. Who's 3? It is local 00 interface right here, right? So the intention is that the intent of this user is to advertise and respond to this DHCP discovers and provide IPs to Chloe or any other end devices, Chloe and Joey's or any other devices on this network. What he's doing is he's providing his gateway IP, his own IP, so that Chloe and Joey send all the traffic to him, and we have a route, a static route, quad 0, pointing back to switch 1. This traffic path would be asymmetric. The routing would be asymmetric. Why? Because Chloe and Joey will respond or talk directly to Pierre because their new gateway is Pierre, and Pierre will forward the traffic to switch 1, and what's going to end up happening is that switch 1 will respond directly to Chloe and Joey. Why? Because there's a static route, a connected route for this network, this prefix, which is 200/29, right? So he knows how to get there. He knows who this is. This is directly, it's in his route table. It is connected to Vlan 10. So he knows how to send the traffic to. So if you do show IPsef, right, and then for example this, he knows Vlan 10, right? All of 4 attached to Vlan 10, right? Receive for Vlan 10 or attached to Vlan 10, right? So that explains basically what the intent here is for Pierre. What is Pierre trying to accomplish? Okay, so what we'll do is, for let's say that Pierre's port, which is 10, let me make sure this is what it is, has been configured to be trusted. Why don't we make it trusted? DHCP snooping trust, and let's disable Arp Inspection DAI, right? So we've done both. Let's clear and let's see if Joey or Chloe would be able to. So we'll do pull an IP, restart system. We'll do the same thing on here. Sudo, let's see. We're going to do okay, let's see what happens. He's replying, see? He is replying to request, and he's also replying to request, right? Let's see what happens. Let's see what switch 1 has, right? No bindings. Let's see what he has. Well, we got 2 bindings on 4 and 6. Guess what's happening now? Pierre has successfully provided DHCP services to Joey and Chloe. What would end up happening is that when Joey is trying to go to the internet, let's say, let me ping the so he's got a 200.6. Let me ping the outbound interface on switch 1. Remember, I'm pinging this. I'm not pinging the gateway 200.1 because that's directly connected to Joey or Chloe. They would know they have the same, they reside and live in that network, in that prefix or that local area network. So they will not try to reach out to the gateway. But when I ping an external network outside of the 200.0/29, now it would do hey, a lookup, recursive lookup. Hey, I can't get to, how do I get to this? Send it to my gateway. And let me show you what the gateway is. The gateway is 200.3. That's unfortunate, right? Let's do a ping and let's see what happens. See, Pierre is receiving traffic from Joey, right? We have an ICMP test here going. We have ICMP going on here, and he's redirecting, right? Once he redirects to 200.1, guess what? He's replying directly. He's receiving this and replying directly to Joey, right? So you see, to his local interface, which is, let me stop this. So he's replying now directly to Joey, right? Because 200.0 is directly attached to Vlan 10. But this doesn't reflect that. This shows that, hey, I'm receiving this source ICMP to this destination, which reside on which is directly connected to me. So, and him is stopped because, well, everything is going through now Ceph, right? That's it. He did the first thing was you receive this packet, is redirecting it to 200.1, right? And then what happens? Ceph takes over, right? So on here, who's 37 is directly connected on 00, right? So let's see responses. The responses are direct. So let's see. On access, we have an access list. Why don't we, just for demonstration purposes, permit host 192.168.100, actually 200.1, and let's see if we get any response, right? Let's ping one more time and stop. Let's enter packets. Let's see what happens, right? He's not gonna respond anymore. Everything is line speed, right? It's in his Ceph table, right? If you do show IP Ceph detail, let me see if we can see that. So obviously everything is going to go to the quad 0. There it is, the quad 0. But let's see the response on so pretty much let me see, where is my switch to? So pretty much what happened is that the traffic goes this way, the ICMP goes this way, it reroutes, it listens, captures everything, all the traffic from Chloe, captures and listens to it, and forwards it to switch 1, and switch 1 talks directly to Chloe. Basically, that's what's happening right now. Now, why don't we fix this and make two things to show run interface G10. Let's make this untrusted and So everything else is untrusted except for the uplink to switch 1. We made it untrusted. Let's see what happens. Oops. Okay. Let's see what happens on Joey or Chloe. So Pierre now isn't receiving anything. He's untrusted. Nothing is being forwarded to him. He's not responding. He's not receiving any DHCP DHCP discover messages. He's not responding. It's dead, right? He's all doing all the responses, right? He's got this IP from who? From switch 1. Same thing, from switch 1. So basically what DHCP snooping successfully has done for us is that it's prevented a DHCP service, a rogue DHCP service from taking down or executing a man-in-the-middle attack on this particular network, right? And what does Arp Inspection further do is that it compares every Arp request and reply, or most Arp requests to a DHCP snooping database, and if you don't belong, it blocks it unless you have explicitly written an access list to permit that transaction, right? Why don't we do this now? So let me see this. We're going to stop this debug. Let me see what's going on here. Chloe has no list, because obviously all the bindings, I have to clear bindings over here. This is what happens is that when basically there is a list that has, hold on, let me see, I need to stop this. There was existing list. I didn't clear the bindings on that, so switch 1 still thinks that those bindings exist, and in order for them to stop is we have to clear the binding and create space in the DHCP pool. So what we'll do is clear IP DHCP bindings, and then we'll start. Okay, if I do show IP DHCP bindings, I shouldn't have any anymore. If we do this again, so I think Joey is good. He's received an IP, right? But Chloe hasn't, so let's do this again. So Chloe should oh yeah, that's because let me release that IP too. There we go. That's what happened when you have clear IP DHCP bindings. DHCP. That's what happens when you get a rogue DHCP. Oh my god, I can't spell DHCP bindings. Star. Show IP. And make sure there's no binding. Alright, perfect. Let's restart both. Okay, and start this one. It should, in principle, should be able to release and renew, but there seems to be a problem. I think route. Okay, there's no route. Let's shut this interface. Shut. Clear IP DHCP bindings. Show IP DHCP bindings. So run section DHCP. So I haven't modified the DHCP server, but I'm just checking on some. Okay, normally Joey and Chloe should, if they're unable to pull a new IP, I will oh, let me see something. Switch to, let's make sure, you know what, let me stop this one and stop that one. Oh boy, what's going on now? Okay, see if I can stop it. Stopping node fails. Let me refresh this. Okay, there we go. It's sometimes there we go. Let's power them up. That should fix this issue. I think PO10 is still trusted. Yeah, it is. So perfect. So in principle, this should work. Debug IP DHCP server event. I will do packets. DHCP server. Say packet and event. Let's do packets. That's fine. What about event? Let's do event. Also, there we go. Joey and Chloe should now should have an IP. Oops, what happened? Ah, of course, it doesn't like abbreviations. If config is 0. Looks like this issue still persists. Yeah, this might be a simulator issue, but all in all is that let's unnall this, stop this. It'll take a second, but let's see what's going on. Okay, it's saying that there's no available IP, and this is let's let me do this. Well, it's not bad to troubleshoot some things like this, so what we'll do is we'll remove this pool and we'll create a pool. It's too easy. Alright, and then we'll create a pool. Oops, yeah. See what happens. Now we've created a pool. Let's see if that fixed the issue. Yeah, it did. So we had to basically, in order to resolve the problem, I had to delete the pool and recreate it. It broke. And that's what happens. That could happen on a live network if you introduce a man-in-the-middle attack, or you do have someone like Pierre that is allowed on the network to run his own DHCP service without preventing or running snooping in order to prevent man-in-the-middle attacks or spoofing. So Now let's enable IP Arp Inspection Vlan 10. As soon as we do this, obviously it doesn't exist in the DHCP snooping database. He won't be able to get to 4. Well, watch, let's see. Am I yes, I am. So it'll take a while. Let me see if I have show run section inspection. I may have that trusted list in there. Yes, I do. That's why it's allowed. And remember, we did this earlier. Oops. We've created a list that permitted this host. So he can, but you will see that Pierre is unable to reach anyone else. Pierre is unable to reach either of the endpoints, Chloe and Joey. So we'll try Joey. He can't get to Joey. You can see he's denying IPs coming from him, Pierre. That's his MAC address and IP address, right? So if you do show interface G00, see, that's the 13.2 Charlie is the MAC address, right? Oops, is the MAC address that is being denied in this ARP inspection. So that concludes this class or this instructional video. We've run into some interesting issues related to the simulator, and that happens. Remember, those are virtual appliances and they're not actual hardware, so I won't be too harsh on the simulator. You have to understand that we like unexpected behavior are part of this science, right? Of science, right? Nothing can, you may expect things to work right, and sometimes they just don't, and you have to troubleshoot. Anyways, thank you for watching, and I wish to see you guys soon.